Hello and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring the standard form of a line. Before we do that, let's talk about the equation for standard form, some examples, and then some pros and cons of standard form. So the equation for standard form of a line looks like this: ax plus by is equal to c. So in standard form, the x and y are on the same side of the equation, and your constant term is on the other side of the equation. So an example of this might look something like 3x plus 2y equals 6. You could have x minus 5y equals 10. So the x and y on the left side, the constant term on the right. Now, some pros to standard form would be that it is easy to identify the intercepts. If you wanted to make a quick sketch of a graph, you could just identify the x-intercept, the y-intercept, plot them on a graph, and connect the 2 points. The cons of standard form is that it is very hard to identify the slope of the line. So if you needed to identify the slope, you would have to rearrange the equation into slope-intercept form. Now, before we get into graphing equations that are written in standard form, let's just practice reviewing how to identify the x and y intercept. So our x-intercept, 1, 2, 3, 4, is here at -4, 0. We went to the left 4 and then 0 up or down. The y-intercept, we're going 0 left or right, but we're going up 1, 2, 3, 4, 5, 6. So our y-intercept is 0, 6. Now, if you're given a table, it's not as apparent what the x and y intercepts before. So I'm going to use Desmos to help you visualize the points in this table. So let me press the plus sign and click table. -2, 3. These should appear on our graph as we plot them. 0, 2, 2, 1, and 4, 0. Now, once you can visualize the points in this table, it's easier to see that the x-intercept is at 4, 0. That's the point where it touches the x-axis. And the y-intercept is at the point 0, 2. That's where the point touches the y-axis. Now, the next question is, what do you notice about the value of y for the x-intercepts? So let's look at our x-intercepts. They want us to notice, what do we notice about the value of y? So let me highlight the value of y for our x-intercepts. So the value of y is equal to 0 on all x-intercepts. All right, next question. What do you notice about the value of x for the y-intercepts? So let me highlight the value of x on our y-intercepts. Notice that on the y-intercept, the value of x is equal to 0. Now, what this means for us is that it's going to be super easy to find our x and y intercepts from an equation. To find the x-intercept, you just set y equal to 0 and solve for x. To find the y-intercept, you set x equal to 0 and you solve for y. So what that means in example 2 is that if we want to graph each of the following and then identify the slope and, identify the intercepts and the slope, all we have to do to find the x-intercept is to let the value of y be 0, which means all we would have left here in our equation to solve is 4x is equal to 12. Now, if we want to find the y-intercept, then all we would have to do is let x be 0 and we would be left with the equation negative 2y equals 12. Now, these are both very easy equations to solve because on the first one, all you have to do is divide by both sides by 4. 12 divided by 4 gives you 3. So I know my x-intercept is 3, 0, and I can plot that. 1, 2, 3. On my second equation, all we have to do is divide by negative 2. So 12 divided by negative 2 gives me y equals negative 6. So I know my y-intercept is negative 6. So 1, 2, 3, 4, 5, 6. Now, if I wanted to make the graph of this line, all I have to do is connect the points. So this is much easier graphing method than rearranging that equation into slope-intercept form. Just identify where does it touch the x, where does it touch the y, connect the 2 points. Now, if you want to identify the slope, then you're going to have to calculate rise over run. So to calculate rise over run, we're going up 6 and over, or to the right 3. So that would be 6 over 3, which is 2. So again, easy to find where the line touches the x and y axis. A little bit harder to find the slope because you have to plot the 2 points, then get rise over run. All right, let's try one more of this. We have the equation 3x minus y equals negative 6, and it wants me to graph the line. So to do that, I'll put 3x is equal to negative 6, and then negative y is equal to negative 6, and I'll solve each of those equations. So for the first one, to get x, I'll simply divide both sides by 3. So negative 6 divided by 3 would give me negative 2. So now I know my x-intercept. And then negative y equals negative 6. I'll divide both sides by negative 1. So negative 6 divided by negative 1, positive 6. So to graph the line, I'll put a point at negative 2 on the x-axis and positive 6 on the y-axis. Connect the line. And then the last thing it wants me to do is calculate the slope. So I'll use rise. I'm going up 6 and to the right 2. So we'll have a positive slope, 6 over 2, which reduces to 3. All right, example 3. Graph each of the following and identify the intercepts and the slope. So I have the equation 2x is equal to 5. Now, in this problem, we're missing the y, but that's okay. Let me show you what's going to happen. You're going to divide both sides by 2. So 5 divided by 2 is simply 5 over 2, which is equivalent to x equals 2.5. So to graph that, I'm going to put a dot on my x-axis at 2.5, about right here. Now, because there is no y in this problem, that means there's going to be no y-intercept. So my x-intercept is 2.5, 0. For the y-intercept, it's not applicable in this problem because there was no y in the equation. So if this line never touches the y, that means the only thing it can do is go vertical because it cannot touch the y. Now, the slope, remember, of all vertical lines is undefined. Okay. Now, what about in an equation where there's no x? Look at b. We have negative 3y is equal to 9. So if I get the y by itself, 9 divided by negative 3 is negative 3. So I have a y-intercept of 0, negative 3, but there is no x-intercept. So plot the point 0, negative 3, and think about how would you have to draw a line that never touches the x. The line can never touch the x, and it has to go through this point. Well, that line would have to be horizontal, because if it was slanted, it would touch the x-axis eventually. Now, remember, the slope of all horizontal lines is 0. All right, example 4. In a video game, you earn 5 points for each jewel you find. Let's highlight that. You earn 2 points for each star you find. Write and graph an equation that represents the number of jewels and the number of stars you must earn. Number of jewels and number of stars you must earn to earn 250 points. Now, they've given us a plot that we're going to use to create our graph. But what I want you to notice about the plot is that the number of jewels is plotted on the x-axis. So that means they want us to let x equal the number of jewels. Now, looking on your y-axis, notice that they said that y-axis is supposed to be the number of stars. So we're going to let y equal the number of stars. Now, we want to write an equation that would help us find the number of jewels and the number of stars you must find to earn 250 points. So I know the jewels are worth 5 points. So that would be 5 times x. 5 times the number of jewels plus 2 points for the stars. So 2 times the number of stars. We want that total points to equal 250. So if I was wanting to plot this graph, because it's in standard form, the easiest way to plot this would be to find my x and y intercepts. So I'm going to find the x-intercept by taking the 5x and making it equal to 250. Then I'm going to find the y-intercept by taking 2y and letting it equal to 250. So for my x, I will divide both sides by 5. So 250 divided by 5 is equal to 50. So I have an x-intercept of 50, 0. So that goes on my x-axis. All right, for the y, take 250 and divide by 2. So that gives me 125. So I know my y-intercept is at 0, 125. That would be about right there. Now, draw a line connecting the 2 points. And now we have the graph of the equation. Now, let's talk about how standard form will often be tested on multiple choice tests, standardized tests, PSAT, SAT, state testing, things like that. So in example 5, it says use the intercepts to determine the equation that best describes the line drawn. So if we want to use the intercepts, let's start by identifying them. So our y-intercept is 0, positive 2. And our x-intercept, 1, 2, 3, 4, is at 4, 0. So we're just going to check each answer choice to figure out which one has the same intercepts as the graph. So for answer choice A, I'll take negative 2x and make it equal to negative 2. And then negative y, make it equal to negative 2. So negative 2 divided by negative 2 would give me x equals 1. Well, that's not the correct x-intercept. We're supposed to have x equals 4. So I'm going to mark out A. Now let's try B. We'll take x and make it equal to 4. And negative 2y, make it equal to 4. So my first intercept is x equals 4. That checks out. All right, let's check the y now. 4 divided by negative 2 is negative 2. But according to the graph, the y-intercept is positive 2. So that does not check out. Both intercepts have to check out to be the correct answer. All right, so let's mark out B. All right, let's try C. Negative x is equal to negative 4. And negative 2y is equal to negative 4. All right, let's check these. All right, for x, I'll have to divide by both sides by negative 1. So negative 4 divided by negative 1 is positive 4. That checks out. Here, we'll divide both sides by negative 2. Negative 4 divided by negative 2. Negative divided by negative is a positive 2, and that also checks out. So now we have found our correct answer choice that matches the graph. And that concludes today's lesson, standard form of a line.